question 1a, which was this one over here. Now we are going to do equation with sets. Now to do equations with sets, I would normally teach my kids the steps that they need to follow, and they need to make sure that they follow all these steps, right? I sometimes feel like it's very unprofessional to write things. I prefer to type, just that for this one here, typing take longer, especially for maths. It takes longer. Let me just give you these steps. I will quickly type them. Steps when dealing with sets. So these are the steps that you need to follow when solving equations with sets, all right? So what are these steps? Step number one, guys, okay, you need to isolate the third. Isolate the third. Now, what do I mean by that? Let me just explain and then write at the same time. So when we isolate the third here, what I'm going to do is to make sure that on the left-hand side, I'm only left with the third. The third here will be that square root and everything that is underneath that square root, okay? Let me just do that quickly. Now, that's what you need to do when you isolate the third. I took -7 from the left-hand side to the right-hand side. When you isolate it, obviously, the sign will change. That -7 will become positive. That's why on the right-hand side, I now have positive 7, right? The next step, what do we do? Get rid of the set, get rid of the set. To get rid of the set, if it's a square root, you square both sides. If it's a cube root, you cube both sides. If it's a cube root, you raise both sides to the exponent of 5. I hope that makes sense. Here, because I'm dealing with the square root, I will simply square both sides. The square root and the exponent of 2 will cross out. This is the fact that when you multiply exponent, remember the square root represents the exponent of the half. So when you take the exponent of the half, you multiply it with 2, it will give you 1. That's why we cross out the square root when it's raised to an exponent of 2. If it was raised to an exponent of 4, we'll still be left with 2x minus 1 to the exponent of 2. But here, obviously, they just cross out. On the left-hand side, you'll be left with you will be left with 2x minus 1. And on the right-hand side, when you square that 7, it'll give you 49, okay? Step number 3. In step number 3, if we had a variable, if our variable was raised to exponent of 2, that would have meant that we need to factorize. And before we can even try to factorize, we will have to make sure that we take all terms to one side. Okay, all terms to one side. And after taking all terms to one side, I'll jump to step number 4. Then you will have had to factorize. And obviously, when you factorize, you have factors raised to equated to the product of 0. And when you have a product of 0, it means one of those factors must be equal to 0. And you will solve each of those factors and solve for the variable. But we can't factorize because this is just a simple linear equation. And step number 5 was going to be solving. So you have to solve or isolate the root that you're solving. Okay, you have to solve or isolate the root that you are solving. So if it's x, you will isolate that x. If it's y, you will isolate that y. Obviously, it will be as simple as this linear expression we have here, we've got here. Okay, that would have been step number 5. Okay, that would have been step number 5. And step number 6 is that once you have solved or you isolated the root, and most students leave this one out, you need to test your solution. You need to test your solution. You need to test if your solution is correct. Okay. Obviously, for now, according to this, it made me do step number 1 and step number 2, and it took me straight to step number 5 because I didn't need to factorize, okay? Because it's a simple linear equation. And how do I solve here? I will start to solve the simple linear equation. I will start by first isolating or simply transposing this -1 over here. It's negative. When it's transposed and crosses the equal sign, it will become +1. So on the left-hand side, I'm simply isolating the root, okay? And this will give me 49 plus 1, and 49 plus 1 will give me how much? Come on now, come on, come on. 49 plus 1 would give me 15, right? 41 plus 1 will give me 15. Okay, you guys can't see it there. Let me just rewrite that. And I will have 2x is equal to 15. And then obviously that 2x is the same as the 2 times x. It will just apply the reverse of the multiplication operation, which is division, by dividing both sides by 2. 2 goes into 50, 25 times, and that is why your x here will just be equal to 25. Normally you would have to test this, but because I only have one root, I don't need to test it. If you have more than two, let me just say at least 2 roots, you will need to test those roots to check if they're correct. What does testing involve? Testing means that you need to take this root and substitute it into the original equation to the extent that your left-hand side will be equal to your right-hand side. I'm going to take this root of x and substitute it where there is x. In the original equation, by the way, I will take this original equation, and wherever there's x, substitute 25. So I'll have square root of 2 times 25 minus 1 and then minus 7, it should give me 0. So I will have the square root of 15 minus 1 minus 7 should be equal to 0. And I'll have the square root of 49. And this will give me 7 minus 7, which will give me 7 minus 7 will actually be 0. So I have 0 is equal to 0, where my left-hand side is equals to the right-hand side. That's how you test your solution, okay? That is how you will test your solution. So when it comes to equations with sets, number 6 is always ignored by most students, and I don't know why. And yeah, that is it. All right. I just didn't have time to actually type all of this. Typing takes longer. It's a lot of preparation. I just wanted to get through this a bit quicker. Just try out question C, where we are solving for X and Y. Obviously, this is simultaneous equations, right? Probably you are mastering that. Thank you for watching yet again. Thank you so much, and have a great afternoon. All I can say is,